Hello student, in our last video we have started our second chapter, that is the photothermal application. In that we have seen some basic introduction about the photothermal application and discuss what do you mean by the solar collectors, different types of the solar collectors. In that we start with the flat plate collector. That means we see the actually what do you mean by the flat plate collectors. Now in this video we will discuss, that is we are going to start liquid flat plate collectors. Actually this is the first point of our syllabus, but we have to know what do you mean by the collector, different types of the collector, and in that we discuss only flat plate collector. First we see the construction. First is the, we know that in last video we have discussed there are different parts of the liquid flat plate collector, that is the absorbing plate, transparent cover, collector box, different types of tubes which are used for the water circulation. Now let's see the construction of the liquid flat plate collector. In that first part is the absorbing plate. It basically consists of a flat surface with high absorbivity for solar radiation called the absorbing plate. Absorbing plate is a plate which have very high absorbivity because there is a absorption of the solar radiation. If the absorption of the solar radiation is more, then we will get more heat, and so that the instrument gives us the high efficiency. That means the performance of that instrument for the collection of the radiation or the heat energy is very high, so that we will get the maximum energy for the utilization. And this is the absorbing plate. It is basically a flat metal plate usually made up of highly conductive and corrosion resistant copper or steel or aluminum with a black surface. It has a black surface. Absorbing plate has a black surface. We know that the black color has the ability to absorb the all radiation, all wavelength radiation, so that the coating of the absorbing plate is a black, and it is made up of conducting, highly conducting material, so that there is no loss of heat. When solar radiation are incident on that plate, immediately it can absorb and transfer to the next part. And also it is a corrosion resistant material because we kept the liquid flat plate collector on the roof or in an open space where we get the sunlight, so that it is a corrosion resistance. There are different environmental parameters, they affect the liquid flat plate collector, that is directly the absorbing plate. So the material which are used for the absorbing plate is the corrosion resistance, and this material is the copper or steel or the aluminum. These are all materials have all these properties, but generally copper is costly, so steel or aluminum is used for the absorbing plate. The thickness of the metal sheet is 1 to 2 millimeter in a thickness. As already we seen in our previous video, the thickness of these plates or the absorbing plate is nearly about the 1 to 2 millimeter in a thickness. Absorber plate are commonly painted with a selective coating which absorb and retain heat better than ordinary black paint and has an absorptance of about 95% for incident short wave solar radiation. As we seen, the absorber plate is coated with a black color, but this color is not ordinary black paint or black color, but which is the selective coating. Selective coating is the coating such that which absorb and retain heat better, and also it has absorptance of about 95%. That means it can absorb nearly 95% solar radiation which are incident on it, and for incident short wave solar radiation, that means short wave. The short wave radiation means the radiation which are not able to complete absorb, but the selective coating has the ability to absorb that radiation. So we are using selective coating instead of ordinary black coating on the absorber plates. The surface of the absorber plate determines how much of the incident solar radiation is absorbed and how much is emitted at a given temperature. The surface of the absorber plate, it means the selective coating or particularly the surface of the absorber plate, determines how much radiations are absorbed and how much radiations are incident at a given temperature, and depending on that the efficiency of the particular efficiency of the flat plate collector. So when the radiation are absorbed in maximum quantity, then the efficiency is obviously high. Now the second part of the liquid flat plate collector is a flow passage, that is the tubes and pipes. The tubes are made up of copper of a diameter 1 to 1.5 centimeter, are soldered in a line with the absorber plate. As we seen, the tubes or pipes are made up of the same material, that is the absorber plate, the material which has the absorber plate, that is the copper, and which is the metal of a diameter 1 to 1.5 centimeter, and are soldered in a line with the absorber plate. That means they are soldered in a one line with the absorber plate. The tubes are soldered, braced or clamped to the bottom of the absorber plate with the pitch ranging from 5 to 15 centimeter, which is generally 5 to 15, variation in the pitch range, that is the 5 to 15 centimeter, in between 5 to 15 centimeter. These tubes, that is the tubes through which the liquid is flowing, is braced or clamped to the bottom of the absorber plate. That means there is a proper flow of water in between in the liquid flat plate collector. So this is the arrangement. These tubes circulate the liquid required for removing the thermal energy from the plate. These tubes, the main function of these tubes is circulate the liquid. That means the liquid is used to remove the thermal energy from the plate, and these tubes are used to circulate that liquid. This is the second part of the liquid flat plate collector. Now third part is the transparent cover plate. It is one or two sheets of a glass of a thickness 3 to 4 millimeter, transparent to the incoming solar radiation and opaque to the infrared re-radiation from the absorber plate. We know that the transparent cover plates play very important role, and which are above the transparent, which are above the absorber plate, which is shown in a figure. This figure. In this figure, the outermost part, very outermost part, which is the airtight enclosure. That means in which all assembly is placed, which is the airtight enclosure. And as we seen before, that is the absorber plate. Absorber plate is above the, there is a small circles, that is the fluid pipes or fluid tubes. These are the fluid tubes, small circles, and above the small circle there is a one line, which is the heat absorber plate with the selective coatings. And after that, that means when the heat is absorbed by the plate, that is the heat absorber plate, and this heat is transferred to the liquid which is present in the fluid tube. Therefore the fluid tube is attached to the absorber plate, or which is exactly below to the absorber plate, and above that the absorber plate there is a layer, one or two layers or more than that, there is a transparent covers. That means they can allow the solar radiation, both, that is the beam radiation as well as the diffused radiation. Beam means direct solar radiation and diffuse solar radiation. And the transparent plate or transparent cover, there is one or two layer which has a thickness, that is a 3 to 4 millimeter, and which is made up of glass, and they should be transparent to the incoming solar radiation, but these transparent plate are opaque to the infrared radiation from the absorber plate. As we seen in figure, there is a absorber plate below the transparent cover. When the solar radiation is incident on the transparent cover, which is transparent to the incoming solar radiation but opaque to the infrared radiation. That means the radiation after passing through the transparent cover, which are absorbed by the absorber plate, but not all radiation are absorbed by the absorber plate, but some radiation are re-emitted or emitted, again re-emitted, that is the infrared radiation. So this is known as the infrared re-radiation from the absorber plate, and this radiation again absorbed by this transparent cover, or it is opaque. Opaque means they do not allow to pass through that is the through the transparent cover plate, so that there is no heat loss. So all the amount of heat is utilized for the heating of the fluid which is present in the tubes. It should have a high transmittance for the solar radiation and should not deteriorate with the time. That means they have very high transmittance. That means they can pass all the solar radiation which are incident on it and should not deteriorate with time. It reduces upward convective and radiative heat losses from the absorber plate. That means there is a reflection or there is a re-emission of the solar radiation which is on the absorber plate. That means there is a reflection or the emission of the solar radiation from the absorber plate, but this transparent cover plate avoid all the emission. That means they opaque to that radiation, so that all heat is utilized. That means there is no heat losses, and it reduces upward, that is convective. We know that there are different types of the radiation or heat losses. That is the convective, radiative and conduction. For radiative radiation there is no requirement of any medium, but convective and conduction requires medium. So this is the heat losses, so that the transparent cover plates are used to reduce the convective and radiative heat losses from the absorber plate. This is the third part of the liquid flat plate collector, that is the transparent cover plate. Now next part is which is the last part, that is the enclosure and the insulation. It is generally made from steel, aluminum or fiber glass. That is the enclosure or insulation. That means in a figure there is the outermost part which is the airtight enclosure, and generally which is made up of aluminum, steel or the fiber glass, so that it can protect the all components of the liquid flat plate collector. This prevents the heat from escaping through the back of the collector, and a layer of insulation is placed behind the absorber plate. That means there is a possibility to leakage of heat or escaping the heat through the back of the collector, but this insulation prevent the loss of that heat. That is, there is a insulation, it acts as a insulation behind the absorber plate, so we get the maximum efficiency or maximum heat. So this insulation play very important role. It is a weather tight container to enclose the above components. That means there are different environmental parameters, such as in a rainy season, wind, there is a wind or some objects which are present in our environment, that is birds, all these things. So it is a weather tight container to enclose the above components. That means it protects the all components of the liquid flat plate collector from the surrounding or the environmental parameter. It facilitates installation of the collector on a roof or in an appropriate frame. That means it gives the appropriate shape to the liquid flat plate collector, so that we can carry from one place to another place, or we can install this liquid flat plate collector on a roof or in a appropriate frame. This is the last part of the liquid flat plate collector, that is the enclosure or insulation. This is the construction of the liquid flat plate collector. That means it is constructed with the help of these different components. This is the schematic cross section of liquid flat plate collector. The outermost part is the airtight enclosure, that is the insulation, which is made up from aluminum or glass fiber. After that, there is a dotted region, which is the insulation. We know that which is the insulation or the enclosure. The last part is the enclosure, airtight enclosure. After that, there is a insulation, which reduces the heat losses, and the small circular parts, which is shown in a figure, that is the fluid tubes, and these tubes are attached to the absorber plate, that is the horizontal line above the small circles, which is the heat absorber plate with the selective coatings. Selective coatings which helps to absorb all the radiations. Now after that is the above the heat absorber plate, there are two layers. First is the anti-reflecting coating, and second one is the transparent covers. Anti-reflecting coating is transparent covers. It's one of the type of the transparent cover. That means the function of both transparent covers and the anti-reflecting coatings are the same. That means they reduces the heat losses by convective and radiative process. And the liquid flat plate collector utilizes both direct solar radiation as well as the diffuse solar radiation, so it is widely used. And there is a small black part on the left hand side and the right hand side inside the airtight enclosure. There is a very small black part, that is a vertical line, which is the cushion support and seat for the glass. We know that the glass has a property, they can easily break, so for the support there is a cushion support and the seat for the glass. This is the schematic cross section of the liquid flat plate collector. Now how it works, what is the working of the liquid flat plate collector, how we get the energy from the solar radiation, that means how we heat the water with the help of solar radiation. Now let's see. When a sunlight passes through the transparent cover and it strikes the absorber plate, its temperature increases until the rate at which the energy received is equal to the rate at which the heat lost from the plate. You know that when we incident the solar radiation or the solar radiation which are coming from the sun, they are passing through the first is the transparent covers, and the transparent cover passes all these radiation. After that, they are incident on the directly absorber plate, and absorber plate absorb all these radiations. Therefore, its temperature increases or it heats up. So the temperature increases, but where? Until the rate at which the energy received is equal to the rate at which the heat lost from the plate. That means the solar radiation absorbed by the absorbing plate, but for what range or for what temperature? The temperature at which the rate which energy received is equal to, that means the rate at which the energy is received to the rate at which the heat lost from the plate. That means there is absorption and emission. When these rates are equal, then the temperature is maximum or temperature increases. This temperature is called as the equilibrium temperature. That means the rate of absorption and the rate of emission both are equal, then this temperature is known as the equilibrium temperature. This equilibrium temperature is much higher than the simple exposed sheet or transparent cover. On a transparent cover or absorber plate, sheet means the absorber plate, on that there is a particular instant, so that the radiations are incident. So the temperature of the transparent cover or the sheet is less than the equilibrium temperature. Equilibrium temperature means the all radiations which are absorbed and simultaneously they emit. When these rate, absorption and the emission rate are equal, then the equilibrium temperature is high, and this is obviously higher than the temperature of the transparent cover. This is the conversion of there is a conversion of the solar energy into heat energy. After absorption of the solar radiation by the absorber plate, there is a conversion of solar radiation, that is the conversion of solar energy into the heat energy, and this heat is transferred to the liquid, that is the oil, passing through the pipes attached to the absorber plate by means of convective heat transfer. And this heat, the generated heat, is transferred to the liquid, and this liquid which is present present inside the tubes or pipes, passing through the pipes attached to the absorber plate, and these pipes are attached to the absorber plate so that the absorber plate transfer the heat to the liquid by means of the convective heat transfer process. There is a convective heat transfer process, and so that the heat is transferred from absorber plate to the fluid, and due to heat there is a heating of water. So our conclusion is that means the last we have to heat the water, so there is a heating of the water, therefore liquid gets heat, and after that this liquid is transferred to the tank for storage. Now this liquid flat plate collector, the main aim, that is the main aim of the liquid flat plate collector is to heat the water, and so that we get the heating of the water. So last step of the liquid flat plate collector, and after that this hot water or this heated liquid is used for the other applications. So it can be stored in a tank. So after that this liquid is transferred to a tank for storage, and after that we will use it for different applications, so such as in industrial, in agriculture, or in some buildings for the hot water service. Now the liquid flat plate collector is widely used because it is easy to construct and it has no movable parts. So this is, and working is also very simple. So this is all about the liquid flat plate collector. This is the basic working principle of the liquid flat plate collector. So it has some advantages as well as disadvantages. First we see the advantages. It is a simple in design, has no moving parts, and requires little maintenance, as we discussed in our previous video. It is a simple in a design and also has no moving parts, so that it can replace from one place to the another place very easily, and requires little maintenance, that is the only cleaning, because there is a dust or some environmental parameters which affects the transparent cover, so that there is a transparency, that may occur. The transparency of the transparent covers may be less, so little maintenance, that is the only cleaning. Second is the main advantage is that it utilizes both the beam and the diffuse radiation. As we seen before, liquid flat plate collector utilizes both the beam as well as the diffuse radiation, so that it has a maximum efficiency, or it has the ability to produce maximum amount of heated water or the hot water. But it has also some disadvantages, but there is only one disadvantage, that is because of absence of optical concentration, the area from which heat is lost is large. As a result, collection efficiency is generally low. There is a loss of heat, that means by the convective or radiative heat losses, there is a loss of heat and which is in large quantity, that is the absence of optical concentration. There is no any particular point on which the radiations are focused. That means there is no optical concentration. So in that there is a loss, that is by the convective or radiative heat losses. So the collection efficiency is generally low. This is the disadvantage of the liquid flat plate collector. It has a different application. First one is the water heating, second one is the space heating or cooling, and third one is the low temperature cycles for the power generation. Water heating, as we seen in liquid flat plate collector. The liquid flat plate collector are used for the water heating or to produce the hot water. Second is the space heating and cooling. That means in winter season there is a use of the liquid flat plate collector for the space heating, and there are different applications, that is heating and cooling. That is this heat energy is used for the cooling. That means in a refrigeration there is a use of liquid flat plate collector. Third one is the low temperature cycles for the power generation. That means for the power generation liquid flat plate collector also used. There are different arrangements or the systems in which the liquid flat plate collector used and which is used for the generation of the power. These are the applications of the liquid flat plate collector. This is all about the liquid flat plate collector. That is we have seen construction, working of it, schematic diagram of the liquid flat plate collector, and the working, how it works. And after that it has some advantages always and disadvantages we have been discussed, and it has some applications. That is 3 applications which we have discussed. So this is all about the liquid flat plate collector. Now in our next video we will discuss the energy balance equation for the liquid flat plate collector. So we will continue it in our next video.